Okay, let's resume the class. So we are going to move on to the first topic, the permutation and the combination. So before that, let me introduce some notation. So they are very simple notation. So what is combination and what is permutation? So here, these are the rough definition of what is meant by combination and what is meant by permutation. So combination talks about selection. Okay, so number of ways to select is the key thing that we want to study. So this is a problem that appears in a lot of cases, like in the textbook problems, you may be asked how many ways to select 2 people from 5 candidates. So this is a selection problem. So we can also ask it in another way, how many combinations are there when we are choosing 2 people from 5 candidates? So selection and combination, they are meaning the same thing. And here, when we talk about combination or selection, the ordering of the items that you select does not matter. So for instance, let's say we have a sun, a moon, a star, and an apple. So if we want to select 2 things, let's say we are selecting the sun and the apple, then whether sun and apple or sun, they are meaning the same thing. Is that okay? So this is meant by selection, or this is one way of selecting 2 items from these 4 things. Okay, so this is the combination problem. And arrangement. So for permutation, we talk about arrangement. So we maybe like there are 5 books, and then we want to ask how many ways are there to arrange these 5 books all together. So by arrangement, the ordering matters. So if we have A, B, C, D, E, these 5 things, the A, B, C, D, E, and E, D, C, B, A, yeah, they mean different arrangements. Okay, so each arrangement is a permutation. So we can rephrase the same problem as how many permutations are there if we have 5 books and then we want to use all of them. Okay, so as an example, so let's say we have again the sun, the moon, the star, and the apple here. So sun, star, moon is one way of arranging 3 of the items inside this collection. And then sun, moon, star, this will be another way of picking 3 items and arrange them. Okay? So to describe a certain, so we can talk about what is this kind of combination. This is a combination that takes 2 items from this group. So we can call this a 2 combination. Is that okay? And then for this one, it is taking 3 items and then arrange them. So we can say that this is a 3 permutation. Is that okay? So first of all, this permutation means that it is a permutation. The ordering of the items matters. And then the number before it tells us how many items are there inside your arrangement. So 3 permutation has 3 items. Okay, 2 combination has 2 items. Is that okay? So this is the notation that I want to introduce. And then for most of the problems, we are interested in counting the number of ways to select or counting the number of ways to arrange. So this is going to be a counting problem. And for this, we defined further notation. The first one is CNR. So CNR is a number. This is a number. So you have already known this already. So this is a number. It tells us that the number of ways to select 2 items from n items. of course, this will be equal to, if you don't like the word select, you use combinations. So it is like the number of, sorry, not 2 items, sorry. This is general, this is R items from N items. The number of R combinations from N items. Is that okay? So CNR means this one. And then we can also define, C here stands for combination. So similarly, we want to ask the number of arrangements are there. So we have PNR. So PNR is the number of ways to arrange R items from N items. So arrange R items from N items means that I take out R items and then make arrangement. So it is equivalent to the number of R permutation from N items. Is that okay? Okay, now so far we have not talked about how to calculate this number of ways. But still, we can do some simple calculation of the special case. So for instance, let us try to find out what is the value of this number. So what is the value of CNN? Let's say n is some number greater than 1. What is CNN? What is the number of ways to select N items from N items? How many ways are there? 1. Very good, 1. So we don't know what is the rule or what are the formulas to calculate this CNR or PNR. But still, CNN, we should know it must be equal to 1. Yeah, because to select N items from N items, you have to take all. There's only one way. You take all. There's no other choice. Arrangement doesn't count, so it must be 1. How about CN1? N, right? Number of ways to take one item out of N items. So I take the first one, or I take the second one, or I take the third one. So it must be N, okay? So I assume general N. So it's not like C01 or C whatever. Okay, how about this one? C32. C32 is equal to, so C32, you have 3 objects, ABC, let's say. I want to take 2 of them. How many ways are there? So I can take AB, or I can take BC, or I can take AC, right? Okay, so this is equal to 3. There are 3 ways. Is that okay? And how about this one? This is P32. Do we know? Now P32 should be similar to C32 because they are talking about selecting 2 items, right? But then this P32, the arrangement of them will count. So I can take AB, and then I get AB or BA. I can take AC, I will get AC or CA. I can take BC, I will have BC or CB. Is that okay? So there could be 6 different arrangements when we take 2 items out of it. So there are going to be 6. Okay. Now so far all of these we can either understand them by intuition, or we can, so the numbers here when they are very small, then we can count them by brute force. Okay. And what is next? So the next one is, let us try to develop the formulas for them. Okay. Of course you know already. So if you still remember this formula, this should look like, CNR looks like something like n factorial divided by r factorial, and then further divided by n minus r factorial. And then this PNR is something similar. You don't, it's like CNR, you multiply this by r factorial. So something like n factorial divided by n minus r factorial, something like that. Okay. But how do we derive a formula like that for this thing? So amazingly, we can do so by using two simple rules. They are so simple that there is no proof. You just believe it. So there are two rules we want to talk about. And they are you can call them the fundamental rules of counting. So we have two rules. One is rule of sum, and then the other is rule of product. Sum is like two numbers adding together. Product is like two numbers multiplying together. Okay. So what is rule of sum? Rule of product. Okay. Rule of sum says, suppose that there are m ways to do one thing, and then there are n ways to do another thing. So there are two things that we want to do, another thing. Okay, rule of sum says the number of ways to do one of the thing is equal to, so there are m ways to do one thing. So like there are m ways that I can have lunch in 水木, okay? And then there are n ways that I can have lunch at 丰原楼. Okay, so how many ways are there to do one of the things? How many ways are there to have lunch at 水木 or 丰原楼? How many ways are there? There should be m plus n. Am I correct? M plus n. Okay? So this is like, the key word here is that to do one of the things, this thing or that thing. So this is or. This is the or case. Okay, how about rule of product? So there's just no way to prove it. It's just so natural that we believe it. Okay? And rule of product. So what is rule of product? So number of ways to do the first thing and the second thing. Will be equal to. So here, maybe 丰原 and 水木 is not a good idea. Like, suppose that in McDonald's, let's say there are 7 different types of burgers. Let's say there are 5 types of drinks that you may choose. And then for each meal, I force you, you must select one of the burger and one of the drink. So this consists of a meal, okay? How many ways to have a meal? So each meal you must have one burger and then one drink, and you have to have both. So there are 7 ways to select the burgers and 5 ways to select the drink. So how many ways are there? So let's say burgers are A, B, C, D, E, F, G, okay? Right? A, B, C, D, E, F, G. Okay, 7. Okay, good. And then let's say the drinks is 1, 2, 3, 4, 5. So you can have a meal like A1. You can have a meal A2, A3, A4, A5. You can have a meal like B1, B2, B3, B4, B5. You can have a meal up to G1, G2, G3, G4, G5, right? So there should be altogether 35 different meals that you can select. You can have. So there are going to be 7 times 5 ways to choose a meal. So this is what I want to say. The number of ways to do, we need to do the first thing. Not only the first thing, but we also need to do the second thing and the second thing. Then in that case, it is m times and. So the key word for this one is and, this and. Is that okay? Of course, we can also talk about 水木 and 风云. So there are n ways to have lunch in 水木 and n ways to have lunch in 风云. How many ways are there to have lunch at 水木 and 风云 together? So each day you need to have 2 lunch. At the same time, one at 水木 and one at 风云. Okay, so this is not natural, but this is what it is going to mean here. So if you need to do 2 things together, both, then you want multiplication. If you want to do one of the things, you do this or you do that, then in that case you use plus. So rule of sum and rule of product. Is that okay? Okay, it looks so simple that how can it help to derive the formula for this one? Okay, let's see. But before that, let us test your understanding. Okay. Now, the following is a tricky question, and this is a tricky question that it is not solved by just rule of sum or rule of product. You need both. Okay. So, suppose that there are 5 Chinese books. And let's say there are 7 English. Okay, so 5 Chinese books maybe. 鹿鼎记, there are 5 of them. Let's say 7 English books, the Harry Potter, there are 7 of them. And then let's say, I don't know what is French book, but let's say there is a series of French book. It has 10 of them, 10 French books. Now, this is our task. Our task is to get 2 books, but in different language. So I may be getting the first book of 鹿鼎记 and the second book of Harry Potter. So this is one way that I choose 2 books with different language. I can pick another book here with the first book in the French. So this is another way. So this is the problem. Every time we need 2 books, and then they have to be in different language. And then we want to ask, so we want to count how many different ways that we can do this selection. How many ways we can select 2 books in different language. Okay, so order does not matter. So as long as there are 2 books, one in Chinese, one in English, okay, this is 2 books. So the ordering of the 2 books doesn't matter. So I want to count how many ways are there. Okay? Yeah, this is, I think this is tricky. This is, if I tell you the answer, it is very simple. Yeah, but this is what I think. The more you know, the harder you find the solution. Because the more you know, you will say, oh, 2 books. Good. There, how many books are there? There are 22 books, right? 2 books, you want to select 2. Then you have 22, choose 2. But then something wrong. 22, choose 2, then you are overcounting something that you don't want. You are double counting something like you are going to select 2 Chinese books. So you should minus 5, choose 2, and then you should minus 7, choose 2, and you should minus 10, choose 2, right? Okay, this is what I meant. The more you know, the more complicated. But let's get to the simple thing, okay? We can actually use rule of sum and rule of product to help. But not just one of them. We need to use these 2 rules together. Okay, so what is meant by rule of sum? So rule of sum says how many ways to do one. Okay, so we can have different ways to do things, right? So first of all, our task is to select books in different language, right? There are just 2 books, okay. 2 books in different language. It can be Chinese with English, or it can be Chinese with French, or it can be English with French. Okay, so the first way may be Chinese with English, And then the second way may be, okay, I just don't use plus. The second way is Chinese with French, and then the third way is English with French, right? Right? In order to select two books in different language, I may be selecting Chinese with English, or Chinese with French, or English with French, right? If I know the number here, if I know the number here, if I know the number here, what should I do? I should just add them together. And this is my solution. Is that okay? Now, suddenly everything becomes simple. The number of ways to select Chinese with English is I have to get one book from Chinese and one book from English. It is going to be 5 times 7. This time this is rule of product. And here, Chinese with French, this is going to be 5 times 10. And finally, English with French, it is going to be 7 times 10. Okay? Is that okay? Now this is going to be much simpler. If this is a problem that the God is keeping a proof of this one, then it should look like this, rather than you are solving it like 22 choose 2 minus 10 choose 2 minus 5 choose 2 minus 7 choose 2. That is going to give the same answer, but this one is far better. Okay? Good. Now, okay, so let's do more. Okay.